In this lesson, we are going to derive some formulas in trigonometry. As you can see here, there are two angles, angle A and angle B. I am going to find what is angle A plus B. This angle is angle A plus B. We are going to derive the formula for sine A plus B. We will also be deriving the formulas for cos A plus B and so on. In order to find the sine of the angle A plus B, I need a right angle triangle with A plus B as one of the angles. Let me make a right angle triangle like this, where the part here is 90 degrees. Therefore, I have a right angle triangle with 90 degree here and A plus B here. So sine of A plus B will be opposite side over hypotenuse. If I name the sides as P, Q, and R here, then sine A plus B will be QR over PR, which is opposite over hypotenuse. Now, I need to make a right angle triangle with angle A, and I make it like this. This is with angle B. So, PR, maybe T, is a right angle triangle where the 90 degree is here. This is a right angle triangle with angle B as one of its angles. Now I have to make another right angle triangle with angle A, and it is formed like this with 90 degree here. Let me name this as maybe S. So we have two triangles, PTR and PTS, with PT as the common side. Both of these triangles are 90 degrees, right angle triangles. When we make this PRT, this angle becomes angle A. This can be easily proved. Now, this QR does not have any connection with these two right angle triangles. Therefore, we are going to split it into two parts using this right angle triangle. This splits RQ into two parts, RN and NQ. So I'm going to write this QR as QN plus NR over PR. Let me split this ratio into two separate ratios, Qn over PR plus NR over PR. Now let me consider each ratio separately. What is Qn over PR? Qn is here and PR is here. Instead of Qn, since Qn does not belong to any of these two triangles, I shift the Qn as ST because they are equal. Therefore, Qn can be rewritten as ST over PR. Now, ST is one side of the pink colored triangle and PR is one side of the blue colored triangle. Therefore, there is no connection between these two. So we are going to make a connection using the common side, which is PT. So I'm going to introduce this PT, which is common to both the triangles, like this. I am multiplying and dividing this ratio by PT. Now let me see what is ST over PT. ST is here and PT is here. So ST is nothing but the opposite side for A and PT is the hypotenuse for this triangle. Therefore, ST over PT will be opposite over hypotenuse for angle A. Therefore, it is sine A. Now, what is PT over PR? PT is adjacent for angle B and PR is the hypotenuse of this triangle. Adjacent over hypotenuse gives cos and it is with angle B. Therefore, Qn over PR is sine A cos B. Let's move on to the next ratio here, which is NR over PN. Let's see where NR is. NR is here and I think this should be PR, I'm sorry. NR over PR and PR is here. So this NR is part of this green colored triangle and PR is part of the blue colored triangle. The side common to both these triangles is RT. Therefore, I have to introduce this RT in order to combine RN and PR. I'll introduce it in the same way I did for PT. So RN over RT times RT over PR. I am multiplying and dividing by RT. What is Rn over RT? Rn is adjacent side for A and RT is hypotenuse for this triangle. Therefore, adjacent over hypotenuse should be cos A, and PT, RT is opposite to B and PR is hypotenuse to B. Therefore, this should be sin B. So let's put it here. Qn over PR is sin A cos B plus NR over PR is cos A sin B. Therefore, if you write it together, sin A plus B is equal to sin A cos B plus cos A sin B. This is the formula for sin A plus B. Cos A plus B will be adjacent over hypotenuse. Cos A plus B will be adjacent side, which is PQ, over hypotenuse, which is PR. Therefore, cos A plus B will be PQ over PR. Now, PQ has to be split into two parts, which is maybe PQ, PS minus SQ over PR. Again, I can split this ratio into two different ratios like this, PS over PR minus SQ over PR. The same way as before, I will see what is PS over PR means. PS is the whole side of the red triangle and PR is the hypotenuse of the blue triangle. So as before, we will introduce this common side PT. Therefore, it is PS over PT times PT over PR. PS over PT is adjacent over hypotenuse for angle A, therefore it is cos A. PT over PR is adjacent over hypotenuse for B, therefore it is cos B. Therefore we have PS over PR as cos A cos B. Now what is SQ over PR? SQ is this side, which can be equated to NT of this triangle. Therefore, SQ over PR will be NT over PR. Again, NT belongs to this green triangle and PR belongs to this blue triangle. The side common is RT. So I have to introduce the RT in between like this, as usual. Now, NT over RT is opposite for angle A over adjacent side in this triangle. Over hypotenuse. Therefore, opposite over hypotenuse is sine and the angle is A. PT RT over PR will be opposite for angle B and hypotenuse of this triangle. Therefore, opposite over hypotenuse of angle B is sine B. So, SQ over PR is sine A sine B, whereas PS over PR was cos A cos B. Therefore, here it becomes cos A cos B, but it is minus sine A sine B. If we rewrite the formula, cos A plus B equals cos A cos B minus sine A sine B. Now we are going to find what is tan of this angle A plus B. We can proceed in the same way as before using the triangles, but it is easier to use this identity. Tan is sine over cos. Since we know what is sine of A plus B and cos of A plus B, we will substitute those answers here. Sine A plus B is sine A cos B plus cos A sine B. And cos A plus B is cos A cos B minus sine A sine B. We need the formula for tan A plus B in terms of tan A or tan B. We don't want it in sines and coses. Therefore, we divide this numerator and denominator by the same term, which is cos A cos B. Dividing the numerator and denominator by the same thing doesn't change the value. So sine A cos B plus cos A sine B divided by cos A cos B in the numerator, and this minus this divided by cos A cos B in the denominator. Therefore, if I take this over this and write it first, sine A cos B over cos A cos B plus, now it is this over this again, cos A sine B over cos A cos B. This is in the numerator. In the denominator we have cos A cos B over cos A cos B. So it is cos A cos B. It is going to be 1 in the next step. This is minus, therefore minus sin A sin B over cos A cos B. Sin A sin B over cos A cos B. Now we can see that there are some terms which are getting cancelled here. Cos B, cos A cos A, and this is 1. And we can see this is sin A over cos A times sin B over cos B. So we are left out with sin A over cos A here and sin B over cos B here. Therefore this is sin A over cos A, which is tan A. There is a plus here. And this is sin B over cos B, which is tan B in the numerator, and in the denominator we have this as 1 minus this is tan A times tan B. Therefore the formula is for tan A plus B is this tan A plus tan B over 1 minus tan A tan B. Let's find more formulas in trigonometry. Now this angle is angle A. This is angle B, and therefore this will be angle A minus B. So I'm actually going to find what is sine, cos and tan of A minus B. This is what we are going to find now. In order to find what is sine A minus B, I need a right angle triangle. Therefore, I make a right angle triangle with A minus B as one of its angles. So this is a right angle triangle where this part is 90 degrees. Therefore, sine A minus B, if I name this again as P, Q and R, sine A minus B will be opposite over adjacent, which is RQ over PR. Now I need to make two triangles with angle A and angle B. With angle A, I can make a right angle triangle like this, where this is 90 degrees. So as you can see, this is angle A and this is 90 degrees, and we have a right angle triangle with one angle as angle A. Similarly, let's make a right angle triangle with angle B. So in this triangle, we have this angle as angle A and this as angle 90. Therefore, this becomes the hypotenuse. There is a small change from the previous part to this part. If you take this as angle A, this becomes 90 degrees, which can be easily proved. Now I have to split this RQ and PR in terms of other sides so that I can use different triangles. So let me split it as this. If I name this as T, let me name this as N and this as S. Therefore, RQ over PR has to be split and written in terms of three triangles, the green one, the blue one and the orange one. So RQ is here, which can be equated to NS. Therefore, RQ over PR can be written as NS over PR. Now NS is a straight line which can be taken as a part of this TS. Therefore, NS is nothing but TS minus TN over PR, and I split and write this as usual, TS over PR minus TN over PR. Let us see what is TS over PR and where they stand. TS stands as one side of the blue triangle and PR is one side of the green triangle. So TS over PR should be combined together using a common side between the blue and the green triangle, which is PT. Therefore, let me introduce the side PT as before. Multiplying and dividing by PT. What shall we do for TN over PR? TN is here and PR is here. Therefore, it is between this orange triangle and the green triangle. Therefore, we introduce the RT, which is common to both. So we introduce the RT in this way. As before, multiplying and dividing by RT in numerator and denominator. So what is TS over PT? TS is this line over PT is this one. Therefore, this forms the opposite over hypotenuse of angle A. Therefore, this is sine A. PT, which is here, over PR, which is here. So PT forms the adjacent side for angle B, and PR is the hypotenuse of the triangle with angle B. Therefore, adjacent over hypotenuse, which is cos with angle B. What is TN, which is here, over RT? We have angle A here. Therefore, Tn over RT is adjacent over hypotenuse, which is cos, and angle is A. RT over PR is opposite to B, and PR is hypotenuse to B. Therefore, this is sine B. So we have sine A minus B is sine A cos B minus cos A sine B as our formula. We can also prove what is cos A minus B. Cos of A minus B, which is here, will be adjacent PT over PR. Adjacent over hypotenuse. PT can be written as before as PS plus ST over PR, and I'll split this and write it as PS over PR plus ST over PR. The thing which we have to see now is what we should introduce in order to make this possible. PS over PR. PS and PR, they are in different places. Therefore, we can introduce something which is common to the triangles. Let's find out which is the triangle they both are in. PS is in the blue triangle and PR is in the green triangle. So the line common to both of them is PQ. So let us introduce PQ in between. PS over PQ times PQ over PR. And for ST and PR, now ST doesn't have any triangle to talk about. Therefore, ST has to be replaced by NR. Therefore, this is actually NR over PR. So what is NR over PR? The side common to these two is QR. Therefore, let me introduce QR. NR over QR, QR over PR. Now what is PS over PQ? Let's look into the triangles. PS is here and PQ is here. Therefore, it is in the triangle with angle A. PS is adjacent side and PQ is hypotenuse of the triangle with angle A. Therefore, it is adjacent over hypotenuse with A. PQ and PR. PQ is adjacent to angle B and PR is hypotenuse to the triangle with angle B. Therefore, it is adjacent to hypotenuse, which is cos with angle B, plus NR over RQ. NR is opposite to, we have already seen that this is angle A. This is opposite to A and RQ is hypotenuse. Therefore, it is sine of angle A. This is times QR over PR, which is opposite over hypotenuse, which is sine B. Therefore, we have cos A minus B will be cos A cos B plus sin A sin B. This is the formula for finding cos A minus B. We can continue proving what is tan A minus B in the same way, in the way we did before. Tan A minus B. We don't have to go into the triangle, but we can use this is sin A minus B over cos A minus B. We can substitute the formulas here. Sin A minus B was sin A cos B minus cos A sin B, and cos A minus B was cos A cos B, and there was a plus here, plus sin A sin B. Again we divide both the numerator and denominator by cos A cos B. You can continue doing this proof and ultimately we'll end up into this formula. Tan A minus B equals tan A minus tan B over 1 plus tan A tan B. And this is the formula for tan A minus B. We have seen some formulas which were dealing with addition and subtraction of two angles. In those formulas we found sin A plus B is equal to sin A cos B plus cos A sin B. Now we are going to deduce more formulas using this. In the place of B, let me write A, which means I am going to use sin A plus A, which is sin A cos A again. In the place of B I am writing A, so cos A and sin A here. Sin A plus A plus A is twice A, therefore it is sin of twice A is equal to sin A cos A plus cos A sin A, which is twice sin A cos A. Therefore sin 2A is equal to 2 sin A cos A is the formula which is known as double angle formula for sin. We can also continue doing the same thing with cos. Let me take cos A plus B and substitute B as A as before. Cos A plus B is equal to cos A cos B minus sin A sin B. If I substitute as B as A, then I get cos 2A is equal to cos A cos A, so it is cos square A minus sin A sin A, therefore it is sin square A. Therefore cos 2A is equal to cos square A minus sin square A is the double angle formula for cos 2A. Let's move on to tan 2A. For that we need what is tan A plus B. Tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. Replacing B as A, I get tan 2A. And I am replacing B as A, so it is replaced in this place. Tan B becomes tan A here and here also. Therefore, it is tan A plus tan A in the numerator, which is 2 tan A over 1 minus tan A tan A, which is tan square A. Therefore, tan 2A is equal to 2 tan A over 1 minus tan square A is the double angle formula for tan. So we have sin 2A, cos 2A and tan 2A. From cos 2A, we can deduce further formulas. Let's say cos 2A is equal to cos square A minus sin square A. By identity, we know that cos square A is nothing but 1 minus sin square A. Therefore, it is 1 minus sin square A minus sin square A, which becomes 1 minus 2 sin square A. This is the second formula for cos 2A. Therefore, cos 2A is also equal to 1 minus 2 sin square A. Let's proceed further. We also know that sin square A can be written as 1 minus cos square A. Therefore, substituting sin square A as 1 minus cos square A and keeping the others as it is, we get cos square A minus 1 plus cos square A. Therefore, which is 2 cos square A minus 1. This is the third formula for cos 2A. So cos 2A has three different formulas. Actually speaking, they are the same, derived one from the other. From cos square A minus sin square A, we get 1 minus 2 sin square A and also 2 cos square A minus 1.